Hey everyone, and welcome to section 5.4 on dividing polynomials. This can be a kind of tricky subject, so we're going to be doing lots of examples, but the best way to explain the process is, of course, by doing. So let's start with some of these guys. For monomials, it really just follows the exponent rules. So this first guy, we would divide the coefficients, divide the x's, which means I'm taking 7 minus 11, and dividing the y's, which means I'm taking 12 minus 6. Of course, 14 over 21 simplifies. So we have 1/3 x to the -4th, y to the 6th. Again, we more or less already did this when we were talking about the rules of exponents. So for the second guy, we'll take 28 over 49, divide the x's, which means subtract exponents. And we get 4/7 x to the -4, y squared. Same exact thing for the third one. Now we see a lot of negative exponents cropping up everywhere. So if you want to, if it makes you feel better, you can rewrite them so that they don't have negative exponents anymore. So for example, this first guy would be 1/3, and we know when we have a negative exponent, we take the reciprocal just of the term with the negative exponent. So we've got y to the 6th over 3x to the 4th. For the next one, same kind of thing. And same for the last one. But actually, this step isn't necessary, so you don't need to do this part unless you are specifically asked to keep your answers with positive exponents. And for the moment, we've got enough to worry about, so why don't we just say we're okay with negative exponents for the time being? Well, all right, now we have 18x cubed y minus 36xy squared divided by -3xy. So how are we going to do this division? Well, so we remember that dividing is really the same as multiplying by the reciprocal. And when we're multiplying, we have to distribute. And then we can divide the individual terms. So 18 divided by -3 is -6. X cubed divided by x would be x squared. And then y divided by y is just 1, so that cancels out. Let's see, we have two negative signs, so my answer is going to be positive. 36 divided by 3 is 12. X divided by x is 1. And y squared divided by y is y. So pretty similar to multiplication. You could also just write the entire thing as a fraction from the get-go. And then break them up into individual fractions. So this first guy reduces to negative 4a because 32 divided by negative 8 is negative 4. A squared divided by a is a. B divided by b is 1. Two negatives on the second term, just like in the first problem. So that's a plus. 16 divided by 8 is 2. A divided by a is 1. B squared divided by b is b. All right, now we took a binomial and divided by a monomial. We kind of know what to expect coming up. And that is a trinomial divided by a binomial. I'm going to show you two different ways to do this problem. The first one is by what we call polynomial long division, which is a combination of some of the most horrible words in the English language. So the setup is very similar to standard long division. And I want to make sure that I have all of the powers in between this largest one and the smallest one. Since I don't have an x cubed, I can just put a 0x cubed minus x squared plus 5x minus 6. All right, now we ask ourselves a similar question to when we're doing long division, and that is, what do I need to multiply x by to get x to the fourth? And the answer to that is x cubed. If I multiply x by x cubed, I would get x to the fourth. But I have to multiply all of the terms in the polynomial I'm dividing by. So I also have to take 2 times x cubed. X to the fourth minus x to the fourth is 0. And then I have 0x cubed minus 2x cubed gives me negative 2x cubed. And now I'm going to do a similar thing to what I do with regular division. I'm going to bring down this next guy. And now I repeat the process. What do I have to multiply x by to get this? That would be negative 2x squared. And then 2 times negative 2x squared is negative 4x squared. This is where we can run into a lot of trouble. Keep in mind that we're going to be subtracting, really. So negative 2x cubed minus negative 2x cubed is 0. That's fine. But when I take negative x squared and I subtract negative 4x squared, I'm really adding 4x squared. So I get positive 3x squared. And I need to multiply x by 3x to get 3x squared. 2 times 3x is 6x. And I get negative x minus 6. And what do I need to multiply x by to get negative x? Negative 1. And of course, I have to distribute that negative. So I have negative 6 minus negative 2. And, you know, there's no shame in writing these things off to the side to keep it straight. So I get negative 4. And this guy doesn't have a variable in it. So actually, this is our polynomial remainder. So you continue until you arrive at a power that is less than the highest power in your divisor. You know, that's pretty rough. So we're going to look at a different trick, and it's called synthetic division. This speeds up these kinds of calculations, but it only works in very specific instances. So this would be a long division, like really long. And we also have what's called synthetic division. This really only applies when you are dividing by something that looks very specific. It has to look like x minus something. Now in our case, we have x plus something, but it's okay, right? We can rewrite x plus 2 as x minus negative 2. And what we're going to do is take that value here, put a little box around it, and now I'm going to write all of the coefficients of all of the exponents from the highest exponent all the way down to the constant term. So the coefficient of x to the 4th is 1. There is no x cubed, so its coefficient is 0. Coefficient of x squared is negative 1. The coefficient of x is positive 5, and the constant term is negative 6. So here's how this procedure works. We take this first number, and we're just going to bring it straight down. Next, what we're going to do is take this, and we're going to multiply it by our negative 2. So we get negative 2. Then we're going to add these two numbers together, which gives me negative 2. And then I'm going to do the same thing again. I'm going to take negative 2 times negative 2, which gives me positive 4. I add those together, and I get positive 3. Now I take 3 and I multiply it by negative 2. I get negative 6. Add 5 and negative 6 together, I get negative 1. Take negative 1, multiply it by negative 2, get positive 2. And there we have it. What we've done here is now division. We've done a super slick form of long division, because this last term here is the remainder. The next term is the constant term. The next term after that is the x term, then the x squared term, and then the x cubed term. And so you see, at the end of the day, we end up with exactly the same answer as before, x cubed minus 2x squared plus 3x minus 1 with the remainder of negative 4. All right, another example. We can do synthetic division on this one because we have something of the form x minus c. So remember, we are looking for things that look like x minus c when we're dividing. And hey, we have x minus c here. So that c, which in this case is 4, goes in our little square. And then I write all the coefficients from the highest all the way to the constant term. So the coefficient of the highest exponent term is 1. That's the x cubed term. There's no x squared or x term. So those coefficients would be 0. And the last term is negative 64. Again, bring the first number down. Multiply this bottom number by 4. Then multiply this 4 by 4. We get 16. 16. And then 16 times 4 is positive 64, which when I add together gives me 0. Right. So again, this would be the remainder. In this case, there isn't one, which is good. Then we have the constant term. We have the x term and the x squared term. So altogether, this is equal to x squared plus 4x plus 16. All right, last example. Here we have 2a plus 3, and a bit of a caution here, because remember, we can only use synthetic division when we are dividing by something of the form x minus c. This is not, right? There's a 2 in front of the variable. So I cannot use synthetic division. So we got to do it the old-fashioned way with long division. So we've got 2a plus 3 on the outside. Then we have our 8a cubed. Remember, I got to include all of the coefficients of the terms in the polynomial. And I have to include from the highest exponent to the constant term. So the highest exponent being 3, it means I have to also include 0a squared and 0a, and then plus 27. All right, now how do I get 8a cubed from 2a? I multiply by 4a squared. That makes, when I distribute, I have to multiply 4a squared and 3, which gives me 12a squared. I'm subtracting, so now I have negative a squared. How do I get negative 12a squared? I gotta multiply by negative 6a. Don't forget to bring down our 0a here. And negative 6a times 3 is negative 18a. I am taking 0, so these guys are done for, but I'm taking 0a minus negative 18a. So actually it's 18a. And I bring down my plus 27. To get 18a from 2a, I gotta multiply by positive 9. And when I distribute, I get 18a plus 27. So I have a 0 remainder, and my answer is 4a squared minus 6a plus 9. And that about wraps it up for polynomial division. Again, this is just one of those things you got to keep practicing. Do lots of examples before it clicks. It's super easy to make a mistake with polynomial long division. So don't beat yourself up if it takes you a bunch of tries to do one problem. These things take time. And actually, that also wraps it up for Chapter 5. So we're going to be moving on to Chapter 6 next. Chapter 6 is concerned with factoring, which is kind of related to division. So look forward to it.